This session is for OCR FP1. The topic is roots of polynomial equations, and we're going to work through June 2011, question 10. So if we start by having a look at what the question is giving us. It says the cubic equation x cubed plus 3x squared plus 2 has roots alpha, beta and gamma. We've got to use the substitution x equals 1 over root u to show that 4u cubed plus 12u squared plus 9u minus 1 is equal to 0. And then in part 2 it says, hence find the values of 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared, and 1 over alpha squared beta squared plus 1 over beta squared gamma squared plus 1 over gamma squared alpha squared. So 10 marks for the question, 5 marks for each part. So let's have a look at part 1. So we've got to use this substitution, x equals 1 over the square root of u. So that means that our equation x cubed plus 3x squared plus 2 equals 0, that is going to become 1 over, now the square root is a half and we're cubing it, so that's 1 over 3 over 2 plus 3x squared, so x squared is going to be 1 over u, so that's 3 over u, plus 2 equals 0. So we have substituted, everywhere we have an x, we've substituted it by the square 1 over the square root of u. Now the trick at this stage is now to take this equation and to take any term that involves roots, we'll leave on this left hand side, and we'll take the other two terms across to the right hand side. And then what we're going to do in order to get rid of these roots, this fractional power of a half, is I'm going to square both sides. So I'm going to square this and I'm going to square this. And as long as we square both sides, then that's okay. So we're going to get 1 over u when we square this, 1 over u cubed, sorry. And when we square this, then we're going to get 9 over u squared. When we square the first term, we square the minus 2, we'll get plus 4, and then we take twice the product, which is going to be 12 over u. And now what I can do is multiply the entire equation by u cubed. So I'll get 1 equals 9u plus 4u cubed plus 12u squared. And you should see that the numbers are beginning to look, it's starting to look right. So all I'm going to do now is to take that 1 across and write the 4u cubed first. Then we have a 12u squared, we have a plus 9u, and now we have a minus 1. And so we have got the answer that we were required. So we now know that 4u cubed plus 12u squared plus 9u minus 1 is equal to 0. So the 5 marks for that question, so if we just have a quick look at how those marks are allocated, then you got 1 mark at this stage for writing that in, so substituting in correctly. You then got a method mark for seeing that you needed, in fact 2 method marks by the time you rearranged it and squared both sides. Sorry, that was another 1 method mark, so 2 in total. You got an accuracy mark at this stage for when you squared the brackets, and then rearranging it and getting the correct form, another accuracy mark. So 5 marks in total for that question. If we then look at part 2 and notice it does say hence, so we are expected to use the result that we've got in the first bit. And of course you needed to see that we used the substitution x equals 1 over root u. Now that implies that u is equal to 1 over x squared. We rearrange that. And so the equation has roots 1 over alpha squared, 1 over beta squared, and 1 over gamma squared. If you remember, the roots of our original equation were alpha, beta and gamma, and we've made that substitution. Now the original equation was x cubed plus 3x squared plus 2 equals 0. And then we found that when we made the substitution, we ended up with 4u cubed plus 12u squared plus 9u minus 1 equals 0. And you just need to be careful that it is this equation, this one that we've just found in the last part, that we need to use, because that now we know has got these roots. This is by using that substitution. So remember that the sum of the roots is given by minus b over a, and minus b will be minus 12 over a, which is 4. So the sum of our roots is minus 3, so that gives us our value for 1 over alpha squared plus 1 over beta squared plus 1 over gamma squared. Now in terms of this second thing, it actually is just a matter, of seeing that what we've done in each case is we've taken the product of roots in pairs. So as long as you can see that actually what we're doing there is we're just multiplying each of these, and so that is going to be the same as c over a, and c is 9 and a is 4, and that, this is just the same as this expression here. As long as you can see, it's just taking the sum of the roots in pairs, 2 at a time. So the answers there are minus 3 and 9 over 4. And again, 5 marks for the question. So if we look at how the marks are awarded, then there was a mark here that for seeing that the substitution that we were using meant that the equation that we got and the answer that we got in part 1 was the equation that we needed to use. So that was that. You then got a B1 mark for writing this down and seeing that it was the sum of the roots, and an accuracy mark to getting a correct answer of -3. And you then also got a B mark here for seeing that it was the sum of the product of the roots 2 at a time, which is c over a, which turned out to be 9 over 4. So 5 marks for that question. So do remember that if you want to watch further videos of questions from the papers, then you can go to the Further Maths Support Programme website and just follow the link.